Good morning. It's August 10th, and this is your daily brief in science. Here's everything you need to know. A curious breakthrough comes from Florida International University and partners turning a waste product into a practical water filter. Researchers convert discarded rice husks into biochar using low-oxygen heating, then blend that biochar with magnesium and aluminum to form a sponge-like material that traps textile dyes. The system targets synthetic dyes such as brilliant green and malachite green and has shown dye removal in lab tests. This approach repurposes a large agricultural waste stream into a functional filtration medium with potential for real-world use. Initial experiments indicate the biochar filter remains effective for at least 5 uses, suggesting durability for repeated treatment cycles. The material's high surface area supports efficient contaminant capture, offering a potentially cheaper and greener alternative to some traditional filtration media. The study, led by FIU chemist Islam Ibrahim Hussein and international collaborators, was published in Sustainable Chemistry and Pharmacy. The project aligns with circular economy goals by combining waste reduction with pollution remediation. Future work aims to move beyond the lab, testing performance in real-world conditions and evaluating the filter's ability to separate other dyes, heavy metals, and contaminants. The ultimate aim is scalable deployment that improves access to clean water for communities in need, while reducing agricultural waste from rice husks and addressing dye pollution in textile-dense economies. A trusted voice on science policy sits down to discuss how trust in science shapes public health outcomes and what that means for vaccination, including measles in schools. The interview features Dr. Jay Bhattacharya and touches on his view that vaccinating children against measles and other routine diseases helps protect school attendance, while noting only a handful of states reached 95% vaccination coverage in the prior school year. It also covers ongoing food safety outbreaks from cyclospora linked to iceberg lettuce across multiple states, to possible salmonella in jalapenos and produce, and a screwworm issue in beef, with CDC and FDA steps to trace sources, intervene, and recall contaminated products. The discussion mentions a potential White House executive order on vaccines and autism, but says specifics aren't finalized, while stressing continued autism research through the Autism Data Science Initiative and evidence-based inquiry. The interview emphasizes countering misinformation and avoiding overemphasis on shooter motives in the context of the CDC shooting anniversary and honors Officer David Rose. It argues public trust fell during the pandemic due to health decisions and messaging, calling for a more open scientific process to rebuild trust and reduce misinformation, and notes that measles outbreaks have been controlled in states like Texas, Arizona, Utah, with targeted outreach to high-risk populations. The conversation revisits the autism prevalence debate, underscoring the need for open scientific discussion without political interference over vaccine links, and calls for renewed public trust in science through scientists freely exploring questions without political overlay as NIH director. It links rising measles cases to eroding trust post-pandemic and criticizes fear-based messaging that fuels vaccine hesitancy, with the segment aired on Face the Nation with Margaret Brennan on August 9, 2026, addressing public health issues and vaccination. China envisions a lunar vista where robot dogs work alongside astronauts to patrol, conduct research, and provide emotional support as part of a coordinated team. The plan, outlined by researchers from the China Academy of Space Technology, centers on astronaut-led decisions supported by autonomous robots that learn and adapt in the Moon's data-poor environment. 2 robot dogs would accompany one astronaut to explore the surface and collect rock samples, while a second astronaut performs detailed scientific work with the autonomous machines, and a third stays inside a pressurized rover to coordinate activities. The broader blueprint places 3 astronauts in a collaborative setup with intelligent robots guided by autonomous systems, aiming to extend human capabilities and safety on longer, more productive missions. Tasks for the robots span resource extraction like water ice and minerals, habitat preparation, routine patrols, environmental regulation, cleaning, plant care, meal preparation, and social interaction to mitigate isolation. Robot dogs are expected to assist with terrain exploration, rock sampling, harvesting water ice, mining minerals, and building with local materials, among other duties. This approach also envisions using lava tubes and in-situ construction for habitat support, while coordinating with an expanded lunar base plan. China plans a follow-up mission in August 2026 to extract water ice at the lunar South Pole to support a sustained human presence, with broader objectives to establish a lunar base by year 2035 and an expanded orbital complex by year 2045 as part of the International Lunar Research Station. Autonomy faces challenges due to the Moon's lack of Earth-like data, requiring continuous learning and adaptation for the robots. The concept emphasizes a balance where astronaut oversight guides autonomous robots, enabling longer, safer, and more productive missions while integrating robotics into exploration, science, and settlement efforts. A tiny organism arrived with big consequences. The zebra mussels spread across the Great Lakes after arriving in the late 1880s via ballast water from ships, reaching 23 states and 2 Canadian provinces in about 15 years. The invasion changed ecosystems by clarifying water and reducing plankton, shifting algae distribution, and destabilizing food webs, with notable impacts on species like whitefish. Economically, the spread clogged intake pipes and infrastructure, with estimated costs ranging from $1 to $1.5 billion. International ship controls and ballast water treatment have been adopted to curb future introductions, but these measures do not remove populations already established. Lake Superior mostly resisted invasion due to its low calcium levels, around 12 milligrams per liter, which prevent shell formation, while Lakes Erie, Ontario, Michigan, and Huron were heavily affected. Since the initial invasion, the mussel population has shifted in deeper waters toward the quagga mussel, which tolerates colder, soft mud environments, while zebra mussels remain dominant in shallower areas. A single female can release up to 1 million eggs in a season, and larvae can drift for weeks, enabling rapid natural spread and overland movement via boats and trailers. Asthma biology is centering on epithelial alarmins like TSLP, along with IL-4/IL-13 signaling and IgE pathways as core drivers, guiding targeted biologics such as OMALIZ-UMAB, anti-IL-5/IL-5R, and anti-IL-4R alpha antibodies, with tezepelumab offering benefits across eosinophil statuses including low counts. Asthma remains a global health crisis, affecting about 300 million people and imposing substantial morbidity, mortality, and economic burden, particularly in low- and middle-income countries. Epigenetic alterations contribute to airway remodeling and memory, suggesting potential reprogramming of airway cells toward a less inflammatory state using epigenetic drugs or miRNA/siRNA approaches, though translation to clinics is still in early stages. Traditionally, asthma therapy centers on inhaled corticosteroids and LABAS, but many patients remain inadequately controlled, facing corticosteroid side effects and adherence challenges, while non-T2 phenotypes require alternative strategies. GWAS has identified roughly 150 to 200 asthma risk loci, with notable signals at 17q12 to 21, ORMDL3, GSDMB, and 5q, IL-33, IL-1RL1, IL-4R. Multi-ancestry analyses enhance discovery and improve polygenic risk scores, especially in non-European populations. Non-coding RNAs, including miRNAs and LNCRNAs, modulate asthma inflammation. MIR155 and MIR21 generally promote inflammation, while other RNAs influence Th2 differentiation, with miRNA-based therapies and inhaled siRNAs targeting IL-4, R-alpha, or TSLP under exploration. For T2 low asthma, macrolides reduce exacerbations, while optimal therapies are still being defined. Early-stage work includes small molecule inhibitors, JAK-STAT, kinase modulators, and gene/cell therapies. There is a shift from SABA-only relief to anti-inflammatory strategies, notably ICS and the ICS-formoterol, AIR/SMART approach, which reduce exacerbations and improve outcomes even in mild asthma. Severe asthma, representing about 5 to 10% of cases, remains highly burdensome and heterogeneous, with eosinophilic and non-atopic/neutrophilic endotypes and complications from remodeling, mucus plugging, and comorbidities. Biomarkers, ENO, blood eosinophils, periostin, breath VOCs, and integrative omics are refining personalized therapy and monitoring, supported by machine learning to predict responses, and GWAS findings point to causal genes through EQ-TLS and functional studies, linking risk variants to gene expression changes in airway cells and pathways like TSLP, IL-33/ST2, and IgE regulation. Epigenetic modifications link environment and gene expression, with DNA methylation changes identified in epithelial and immune genes. HDAC2 downregulation links to corticosteroid resistance, suggesting strategies to restore chromatin balance. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.